Right, what we're going to do here, we're going to be looking at shapes of molecules and ions, and we'll be going through to do 4 objectives really. The first one is you should know the basic shapes of simple molecules or ions. You should also know the shape angles. That's the first video. The second video will show how to do 3D diagrams, predict and work out the shapes and bond angles of molecules and ions. We'll try several examples and work out the shape and the name of it and also the bond angle. That's the second video. It may overlap, we might do some 3D diagrams in this video. Okay, right, so let's start off then by looking at what you need to know in terms of basic shape names. Okay, now these shapes you may have come across in your class already, so let's start off from here. If you've got 2 electron regions, I'll explain what this is in a minute, but let's just summarize this. You can always come back to this page. 2 electron regions, right? Notice what I'll tell you what that I mean by that later on. 2 electron regions, the shape will be linear. 3 electron regions, it's going to be called a trigonal planar. I'll show you examples, little models in a second. If it's got 4 electron regions, it's going to be tetrahedral or trigonal pyramid. 5 electron regions, it'll be trigonal bipyramid or T-shaped or seesaw shape. We'll see what that means in the examples. Okay, number 6. If you've got 6 electron regions, then the shape name will be octahedral or a square-based pyramid. Okay, and we'll be able to tell which one it is. Right. Now, some basic rules of what you need to do to predict the shape. First of all, make a rough sketch of the molecule or ion. Okay, number 2, draw dots and crosses for bonds and for lone pairs. Check that you've got the correct number of outer electrons, called valence electrons, hence valence shell electron pair repulsion theory. Number 4, a negative charge means that we have 1 extra electron, and a positive charge means 1 less electron. We'll then sketch again using 3D, and then finally we'll decide the basic shape. Now, if this sounds a bit confusing, don't worry, we'll try some examples and then you'll be able to work it out yourself fairly easily. Okay, but first of all, let's look at some of the basic shapes. First of all, you have a linear molecule. For example, I've got here carbon dioxide, right? Linear. Okay, now I know we've got double bonds, that doesn't matter, that's still 1 electron region and that's another electron region. So that's 1 electron region and that's another electron region. If you've got 2 electron regions, it has to be linear. Now, the key with the VSEPR theory is that electron pairs repel and they will get away from each other as far as possible. Now, if you've got 2 electron pairs here and here, then the furthest they can get away from each other is in a linear shape. Hence, we have a bond angle of 180 degrees, right? 180 degrees if it's going to be a linear shape. Now, if this was just single bond and that was a single bond, you could draw the electron pairs, look, like that. Okay, 1 electron bond, 1 bond and 1 another bond, so 2 bonds, linear. Then we come on to 3 electron regions. Here we have, there's the electron pairs in the bonds. So we've got 1, 2, 3 electron regions, and it's going to be a flat molecule and trigonal. Hence, you can call it trigonal flat or trigonal planar, to be more precise. If you've got 4 electron regions, 1, 2, 3, and you got a lone pair, that's 4 electron regions. Now, you might think that's tetrahedral, therefore, but you look at the atoms to decide the shape, and you got 1, 2, 3 atoms connected to the middle. 3 atoms is going to be trigonal pyramid. It's going to be a pyramid shape. These electron pairs here are more repulsive than the bonding pairs. Let's just draw them in. Okay, so 1, 2, 3 electron regions here and 1 more electron region there. That's what causes this molecule to be a pyramid shape. Now pyramid shape, let me just show you. Here we are, look. I've got a molecule of a pyramid. It's ammonia, for example. There's electron pair. We're looking at these three to decide the shape, and it's a trigonal pyramid. Okay, these lone pairs repel the bonding pairs. Okay, this one here, 1, 2, 3, 4, all of them are bonding pairs. Let's draw them in. 1, 2, 3, 4 electron regions, and therefore that has to be a tetrahedral shape. Okay, let's look at this one here next. If you've got 5 electron regions, 1, 2, 3, 4, 5, then it will be a trigonal bipyramid. Let me show you that one. Okay, here we are. There we go. Trigonal bipyramid. Right, 5 atoms attached, or 5 ions attached to the central atom in the middle. Okay, there we are. Now, it's called a trigonal pyramid, bipyramid, because you can draw a pyramid. Look, oops, you can draw a pyramid. Not very good. Probably imagine that's a pyramid shape at the top, and you can draw another pyramid on the bottom, and so bipyramid, and it's a trigonal base, hence trigonal bipyramid. Okay. If you've got 1, 2, 3, 4, 5 electron regions again, but one of them is a lone pair, then the lone pair will sit on the equator. Now these ions here, or atoms over here, sorry, that one, and this one are sitting on the equator. For example, imagine that's a globe. If you imagine these 3 are on the equator, so they're called equatorial ions or atoms. And these 2 are sitting on the north and south poles, or the axes. So these 2 are called the axial atoms or ions. So the ones on the side equatorial, and these 2 are axial. If you've got trigonal bipyramid, the lone pairs will always sit on the equator. Okay, that's one lone pair. If you've got 2 lone pairs, then again they will sit on the equator as well. 1, 2, 3, 4, 5 electron regions again. Okay, now this one is called a trigonal bipyramid, like I've just explained there. This one, on the other hand, you can imagine, is actually a seesaw shape. Now if I just draw that out like that, can you see that that's a seesaw shape? This one is a T shape. Okay, there it is, there and there. Okay, but they have to have 5 electron regions to have trigonal bipyramid, or a seesaw, or a T shape. And finally, come to the octahedral one. You have 6 electron regions. There we are. And when you have 6 electron regions, it's got to be octahedral. You might think, well, why is it octahedral? Well, you can draw a pyramid. Again, just draw this. Okay, now that, I draw that right. Join up all the atoms there. Can you see that's a square-based pyramid on the top? You could draw a square-based pyramid on the bottom as well. And if you count the number of sides, you've got 4 sides on the top and 4 sides on the bottom, so 8 sides, hence it's called octahedral. Now when you have lone pairs in an octahedral shape, you've got 6 electron regions, but one of them is a lone pair. The lone pairs now will sit on the poles, or the axes. So here's one lone pair sitting on the axis, the south pole if you like, and now you've got this shape, which is a square-based pyramid. Okay, and if you've got 2 lone pairs, they will sit on the north pole and the south pole on the axes, therefore leaving you with a flat molecule, and it's a square planar molecule. Okay, let's now go back and look at the bond angles. Now don't worry, we will go through them. We'll go through some examples, and you'll get an idea how this works. Okay, so let's just first look at the bond angles here, and video 2 will explain by giving examples how to work these things out. Okay, we've got one bond angle here, a linear molecule, 180. Bond angle here, remember this is flat, so the bond angle will be, let's use that. Bond angle will be 120 degrees. Okay, over here, now originally it was tetrahedral, 1, 2, 3, 4 electron regions, tetrahedral, and the bond angle, let's look at this one first. Bond angle is 109.5 degrees. This case, again, is tetrahedral type of shape, but you've got a lone pair, so it makes it a trigonal pyramid. When you have a lone pair, that reduces the bond angle by 2.5 degrees. So from 109, reduce it by 2.5, you're going to get 107 degrees. Okay, an example of that would be ammonia, right? So e.g. ammonia. That one, example, beryllium chloride. That one, oh gosh, hydrogen, lithium, barium. For example, boron chloride. That one, CH4 or SiH4, for example. Okay. Next one, trigonal bipyramid. Now in this one you have actually 2 bond angles. This is the only molecule you got 2 bond angles. This one here is 90 degrees, and then in this one here, that one there, is 120 degrees. So you got 2 different. Let's look at the next one. And this one here, you only have 1 bond angle only. Everything is 90 degrees. Okay, 90 degrees. That one is 90 degrees, and that one again is 90 degrees. Okay, 90 degrees. So what we've just done there, we've had a look at the types, the simple shapes of molecules, the different 5 or 6 different shapes of molecules and their bond angles. We've also been able to draw 3D, I think, but we'll come back to 3D drawings in our next video. Okay, we'll stop there.